Now, I'm going to give you a question which is related with the horizontal circle, and we have just done the concept, which is the conical pendulum. Let us see how we are going to apply that concept here in the question number 9. A plane traveling at the speed of 180 along a horizontal circle makes an angle of 35 degree to the horizontal as shown in the diagram here. The lift force L is acting in the direction shown. Calculate the radius of the circle which this aeroplane is going to move in. So this is clearly a case of conical pendulum like this, and this will be some kind of center there, and this aeroplane is going to move in this circle. So we want to find the radius. Okay, I will write small r, that is better. Yeah, for the radius. Now this angle theta is given as 35 degree, but as I have already shown you in the theory that we will be either interested in this or this angle, isn't it? So we have to first find whether this angle is equal to 35 or not. We have to see that. Okay, so let's see. So this is 35 and these are the two parallel lines. So this angle will be 35. These are alternative interior angles. If this is 35 and this angle is 90, so this becomes 90 minus 35. And this angle is also 90 degree. So it means that this will be 35 degree, no doubt. Well, I think it is clear to you. Like, first of all, this angle is given 35, then this angle becomes 35 because of alternative interior angles. Then this angle is a right angle triangle here, and that is why this will be 90 minus 35. And then this angle is also 90, so it is like 90 minus 35 again. So this is like, that is why this angle is 35. Okay, so when we know this angle, now we can apply our theory. So how to do this now? Okay, this is going to be the centripetal force. This is going to be the weight downwards. So the most easy, like the easiest of all the methods was to create a right angle triangle. So this is the right angle triangle now, and this angle is also 35 degree. This is the right angle triangle. I have found that this angle is 35 degree. This will be the lift force, which is L. This weight will be written here. So vertical will be weight, and this will be the centripetal force, which can be written as Fc. The weight is known, the velocity is known, and the weight is not known. The speed is known. Okay. So the centripetal force is mv square by r, and the weight is not known. Only the speed is given. Calculate the radius. Okay. Let me think, please. I have not done this question earlier. I saw this question there and I thought that it is very good question. So we would be doing it. But anyways, there will be something here. The weight, this. So tan theta, let us go for tangent 35. So that will be FC divided by W. Yes. And FC will be mv square by r. And the weight will be m into g. So m and m is not required. It will be v square divided by rg and tangent 35. So that we now know. So with the help of calculator, we can find the velocity is given as 180. The radius is unknown and gravity can be taken as 9.81. This will be tangent 35. So I'm not using my calculator now, and we are not wasting time for that. So from this equation, you can find the radius. So overall, I have told you, like, how are we going to think in these kind of questions? We have to create this kind of triangle there. Okay, and we will write all the forces there. Okay, because the force, this triangle is known as force triangle. This force triangle becomes similar to this triangle. Okay, so that is why the angle will be the same. So this is 35, this is 35. Accordingly, we can find the tangent theta and we can see how are we going to do this. So there are many methods, there will be many ways. If something else will be the unknown, like what is the weight or what is something else, if they want to find that, there will be some other method. But for this question, this is how we do it. I've just tried to give you an example, a feel of how these conical pendulum questions can occur in your examination. Okay, so this is about the horizontal circles. So now after this video, I believe we would be moving into the vertical circles, which is a very important topic, and do not miss that. Okay, dear students, see you there. Bye.